The morning of February 3rd, 1944 began the way most mornings began at RAF Boxted, with fog so thick it pressed against the corrugated iron walls of the briefing hut like a living thing, and with a particular silence of men who had already done the math and did not like the answer. Colonel Hubert Zemke stood at the front of the room beneath a cloth-covered map. He was 30 years old, lean, and precise in a way that combat command a man to become precise, because imprecision kills people, and he had already watched enough of them die. His pilots sat in rows on wooden benches, their leather jackets still smelling of the previous day's oil and altitude. They were the 56 Fighter Group, the Wolf Pack, and they flew the Republic P-47 Thunderbolt, the largest and heaviest single-engine fighter the United States had ever sent into combat. Zemke pulled the cloth from the map. The red string marking the mission route ran east across the Channel, across Belgium, across the Rhine, and terminated deep inside Germany, further than they had gone before, further than the fuel charts said they should go. The room went quiet in a different way. "We're going to Oschersleben," Zemke said, "and we're going all the way. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today." What Zemke did not say, what no one in that room needed to say, because every pilot present already understood it the way a man understands a wound, was that Oschersleben was 320 miles from Boxted. The P-47 Thunderbolt, by the calculations of every aeronautical engineer at Republic Aviation's plant in Farmingdale, New York, had a combat radius of approximately 175 miles on internal fuel. To reach Oschersleben and return, a Thunderbolt pilot would need roughly twice what his aircraft was designed to carry. That gap, 145 miles of German airspace between what a Thunderbolt could do and what the 8th Air Force needed it to do, was what had been killing American bomber crews since the autumn of 1942. And in the winter of 1944, a group of engineers, a handful of obstinate Republic Aviation test pilots, and one very particular modification were about to close it. To understand why this mattered, why the difference between a combat radius of 175 miles and 320 miles was the difference between winning and losing the air war over Europe, you have to understand the machine at the center of the story. You have to understand what the P-47 Thunderbolt was, and what every expert in 1942 said it could never be. The Republic P-47 Thunderbolt was, by any objective measure, a ridiculous aircraft. When the first production models arrived in England in January of 1943, British mechanics walked around them in circles the way a man walks around a car that has been parked across two spaces, trying to decide if they were looking at a fighter or at some kind of industrial accident. The Thunderbolt weighed 7 tons fully loaded. Its Pratt & Whitney R 2800 double Wasp radial engine displaced 2800 cubic inches and produced 2,000 horsepower. The engine alone weighed nearly a ton. The fuselage behind it was deep and round, like an enormous barrel that someone had accidentally attached wings and a tail to. The pilots who flew it called it the jug, as in a milk jug, and the name was not affectionate. It was honest. What the Thunderbolt had in its favor was survivability. That R 2800 radial was air-cooled, which meant it had no radiator to puncture, no coolant lines to sever. Pilots flew Thunderbolts home from combat with cylinders shot away, with oil lines severed, with entire sections of the airframe missing. The aircraft could absorb punishment that would have turned a more refined machine into a debris field. In a diving attack, it was brutal and effective. It carried 8 half-inch Browning machine guns, 4 in each wing, and when it pushed over into a dive from 30,000 feet, it reached speeds that very few German fighters could match on the way down. But what it could not do, what the physics of its enormous fuel consumption absolutely prohibited, was stay in the air long enough to protect American bombers all the way to their targets. The men flying those bombers understood this limitation better than anyone. By the autumn of 1943, the 8th Air Force was losing crews at a rate that threatened to end the entire daylight bombing campaign before it achieved anything decisive. On October 14th of that year, the mission the crews called Black Thursday, 60 B-17 flying fortresses were shot down over Schweinfurt. 600 men killed or captured in a single afternoon. The German fighter controllers had learned to watch and wait. They tracked the American formations on radar, identified the moment when the P-47 escorts reached the limit of their fuel and turned for home, and then they unleashed everything they had against the naked bombers. The tactic worked with terrible regularity. At 8th Air Force Headquarters at High Wycombe, the staff officers studying the loss reports understood the geometry of the problem with brutal clarity. The bombers could reach the German industrial heartland. The fighters protecting them could not. Every mile east of the Rhine where American fighters were absent was a killing ground, and the Germans had mapped every inch of it. The solution that would eventually come, the P-51 Mustang fitted with Packard-built Merlin engines and paper drop tanks, is a story that gets told in the history books. But before the Mustang arrived in sufficient numbers to change the arithmetic of the air war, there was a different solution being tested, argued over, and very nearly discarded. A solution that lived not in a new aircraft, but in a modified existing one. A solution that a significant number of Republic Aviation's own engineers said was physically impossible, aerodynamically irresponsible, and potentially fatal to the pilot who tried it. The solution was a fuel tank, but not the kind anyone had tried before. To understand why the modification was considered so dangerous, you need to understand the standard external fuel tank arrangement that the P-47 was already using by late 1943. The Thunderbolt, by that point, was routinely carrying a single 75-gallon drop tank on a centerline pylon mounted beneath the fuselage. The tank was made of pressed steel, cost approximately $60 to manufacture, and extended the aircraft's combat radius from 175 miles to approximately 230 miles. This was useful. It was not enough. The 8th Air Force's target planners needed 250 miles, then 300, then further still as the campaign shifted from the French coast toward the industrial centers of central Germany. The logical response, at least on paper, was simple: add more fuel. The complication was that the P-47's fuselage centerline pylon could only carry one tank at a time, and hanging a single larger tank beneath the fuselage introduced control problems as the aircraft's center of gravity shifted during a fuel burn sequence. Republic's engineers had calculated the safe margins. They were not generous. In the spring of 1943, an engineering team at Republic Aviation began investigating what would happen if the P-47 carried not one centerline tank, but two wing-mounted external tanks simultaneously. The concept was straightforward in theory. Fit a pylon to each wing. Hang a tank from each pylon, use the external fuel first on the outbound leg, and drop the tanks when the fighting started. The math, if it worked, would give a Thunderbolt pilot roughly 450 gallons of external fuel on top of the 305 gallons it carried internally. A total fuel load approaching 750 gallons. A potential combat radius approaching 325 miles. The engineering team ran the calculations. Then they ran them again. Then several of them wrote formal objections. The problem was structural. The P-47's wings had not been designed to carry the combined weight and aerodynamic load of two fully fueled external tanks simultaneously. A 75-gallon steel tank weighed, when full, approximately 512 pounds. Two of them, mounted outboard of the main landing gear wells, place an asymmetrical bending load on the wing that Republic's original stress analysis had never contemplated. The engineers calculated that under certain combat maneuver conditions, particularly high-speed rolling pullouts and the violent snap roll entries that Thunderbolt pilots used to reverse direction in a turning engagement, the pylon attachment points might fail. A tank departure at high speed in combat maneuvering was not merely an inconvenience. It was potentially catastrophic. The departing tank could strike the aircraft's control surfaces. It could strike the tail. Under the wrong circumstances, it could kill the pilot before he encountered a single German fighter. There was also the question of fuel management. Using external tanks efficiently required careful sequencing. The pilot needed to run the external tanks down before switching to internal fuel, ensuring the aircraft's center of gravity remained within acceptable limits throughout the flight. In practice, over hostile territory, often under fire, frequently at 30,000 feet, where cognitive performance is measurably degraded by oxygen limitations, this was a significant additional workload. Engineers at Wright Field in Dayton, Ohio, who reviewed Republic's preliminary data, sent a memorandum to 8th Air Force headquarters stating that the dual wing-mounted tank configuration introduced unacceptable risk under combat conditions. The memorandum was sent in June of 1943. By that autumn, the 8th Air Force was losing bombers at a rate that made the phrase unacceptable risk seem almost quaint by comparison. The man most directly responsible for pushing the dual tank program from the drawing board into an actual aircraft was not a senior officer with stars on his collar. He was a Republic Aviation test pilot, an engineer named Carl Bellinger, and his position on the safety objections raised by his own colleagues was approximately as follows. Fly it and find out. Bellinger had been with Republic since 1941. He understood the P-47 structural margins the way a surgeon understands anatomy, not as abstract numbers on a stress diagram, but as felt knowledge, acquired through thousands of hours in the aircraft itself. He had taken Thunderbolts through maneuvers that the flight manual explicitly prohibited, not out of recklessness, but out of a specific need to know where the real limits were rather than conservative ones the engineers had drawn on paper. His view of the dual tank problem was not that the structural concerns were wrong. They were not wrong. His view was that the failure mode was survivable if the tanks were released properly, and that the practical value of the extended range was so enormous that it justified the development effort. He was not without opposition. Within Republic Aviation's engineering department, a faction maintained that the correct solution to the P-47's range problem was not field modifications to an existing design, but an entirely new aircraft. The P-47N, a longer-range variant with a clipped wing and a larger fuel bladder built into the fuselage itself, was already in preliminary development. The engineers who favored this approach argued that attaching improvised external hardware to a combat aircraft was fundamentally the wrong method, that the risks were unpredictable, that maintenance and field conditions would introduce variables no laboratory test could account for, and that the smart move was to wait for a properly engineered solution. Bellinger's counterargument was that properly engineered solutions took time that American bomber crews did not have. In the winter of 1943, as the 8th Air Force sustained its worst losses of the entire war, Bellinger's position was tested against reality. He began flying the dual-tank configuration in earnest at Republic's Farmingdale facility. The early tests confirmed the structural concerns. At high-G maneuver entries with full external tanks, the pylon loads were indeed approaching design limits. The solution he and his team developed was procedural and mechanical simultaneously. Procedurally, the pilot protocol mandated that external tanks be dropped before any combat maneuvering, not when the enemy appeared at long range, but at the moment the pilot transitioned from cruise flight to combat profile, regardless of whether the tanks were fully empty or not. Mechanically, Republic modified the pylon attachment fittings and added a positive lock jettison mechanism that could be operated reliably with a gloved hand in cold cockpit conditions. The modified system was tested through the autumn of 1943. The test results were, by the conservative standards of the engineering objectors, mixed by the standards of what the 8th Air Force needed. They were good enough. By December of 1943, the 56th Fighter Group at Boxstead had received its first allotment of the dual-tank pylons and was beginning the process of integrating them into operational planning. The reaction from the pilots was remarkably similar to Reaction P. 51 pilots had their first look at British paper drop tanks, a combination of skepticism, dark humor, and a particular resignation of combat airmen, who have learned that the people making decisions about their equipment live in buildings that are not being shot at. The tanks themselves, in the initial production run being fitted to 56 Group aircraft through late 1943 and early 1944, were not paper. They were a combination of steel and composition materials, heavier and more expensive than the later British-influenced paper tanks that would become ubiquitous by the spring of 1944, but functionally sound. A pair of 75-gallon steel tanks weighed approximately 1,024 pounds when full. To a pilot who already felt like he was flying a refrigerator, adding the equivalent of 5 adult men to wings in the form of external fuel was not a comfortable proposition. The pilots were not comforted by the briefings on tank jettison procedures either. The procedure required a 2-step action: arm the jettison circuit on the electrical panel, then pull the tank release handle on the instrument panel. Under normal circumstances, at altitude, with both hands free and the aircraft in stable cruise flight, This took approximately 4 seconds. Under combat conditions, adrenaline elevated, gloves on, aircraft potentially in a bank, the 4 seconds was optimistic. The early jettison mechanisms had a documented tendency to stick in cold temperatures, and at 25,000 feet over Germany, the cockpit temperature regularly dropped to 30 degrees below 0 Fahrenheit. Several 56 Group pilots refused the tanks outright during the first weeks of the program. Their reasoning was not cowardice. These were men who flew into German anti-aircraft fire several times a week, but a specific, experienced judgment that a stuck jettison mechanism in a combat engagement was more immediately dangerous than a shorter fuel range. Colonel Zemke heard these objections and did not dismiss them. He was himself flying the dual-tank configuration, logging hours in the modified aircraft before he asked his pilots to take into combat, which was exactly the kind of leadership the 56 Group had come to expect from him, and exactly the kind of leadership that distinguished functional combat units from dysfunctional ones. What Zemke found in his personal test flights through December and January was that the structural concerns were real, the jettison procedure was workable if practiced, and the range extension was transformative in a way that no briefing document adequately conveyed. Over the North Sea, running outbound on external fuel at 26,000 feet, he could feel the difference between what his fuel gauge said and what every previous mission had allowed. He was going somewhere that a Thunderbolt pilot had not gone before, and whatever waited at the end of that fuel burn, it would not be a German fighter controller watching him turn for home. On January 11, 1944, the 8th Air Force launched the largest single mission it had yet attempted. The target was German aircraft manufacturing facilities at Ostersleben, Halberstadt, and Brunswick, the factories producing the Focke-Wulf 190 and Messerschmitt 109 that were destroying American bomber formations with such methodical effectiveness. 663 heavy bombers were dispatched. The mission was, by intent, a direct assault on the Luftwaffe's production capacity. The 56 Fighter Group flew escort. For the first time in the war, Thunderbolts carrying dual external tanks pushed their coverage zone past 300 miles. They did not reach Ostersleben. The full crossing of that distance would require further refinements to fuel management procedure, but they held the German fighters off the bombers for 30 minutes longer than any previous P-47 escort mission had managed. 60 bombers were lost on the mission regardless. The losses were catastrophic, and a mission abort was ordered mid-flight due to weather over the primary targets. But the data from a 56 Group's performance confirmed what Bellinger's test had indicated. The dual-tank configuration worked in combat. The jettison mechanisms functioned under fire. The structural failures the engineers had predicted did not materialize. At 8th Air Force Headquarters, the mission report landed on the desk of Brigadier General William Kepner, commander of 8 Fighter Command. Kepner had been pressing for extended-range escort capability since taking command the previous September. He read through the combat reports, noted the fuel management data, and sent a priority message to Republic Aviation and to Wright Field. The dual-tank program would be accelerated. Every P-47 Group in England would receive the pylon kits as quickly as production and shipping allowed. The engineers at Wright Field who had written the June memorandum about unacceptable risk did not formally withdraw their objections. But the missions kept going deeper, and the Thunderbolts kept coming back. If you find the story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The refinement that moved the program from promising to decisive did not come from Republic Aviation's engineering department. It came from the ground crews at Boxted, Halesworth, and Duxford, the mechanics who were fitting the pylons, fueling the tanks, and then watch what happened when the aircraft came back, or did not come back, and try and understand why. The early pylon kits had 2 persistent failure modes. The first was a cold weather jettison problem already mentioned, mechanisms sticking at altitude, requiring pilots to work the release handle repeatedly under conditions that were hostile to fine motor control. The second was a subtler issue involving the fuel feed sequence. When a pilot switched from external tanks to internal tanks at altitude, there was a brief interruption in fuel flow as the engine-driven fuel pump reprimed the internal system. In normal cruise flight, this interruption lasted approximately 2 seconds, during which the engine ran on residual fuel in the lines. In most circumstances, this was harmless. But the pilot performed the tank switch while pulling G. During a climbing turn or an evasive maneuver, the combination of reduced pump efficiency and centrifugal fuel displacement could extend the interruption to 5 or 6 seconds, long enough to produce a noticeable power reduction at exactly the moment a pilot needed all the power he had. The solution to the first problem came from a 56-group crew chief named Sergeant Anthony Majewski, who modified the jettison mechanism actuating linkage on his assigned aircraft, using components cannibalized from a damaged tank release assembly, increasing the mechanical advantage of the release handle and making it operable with one gloved hand and a positive, single-motion stroke rather than the two-part procedure the original design required. Majewski's modification was unofficial, undocumented, and immediately copied by every other crew chief in the 56 group's maintenance section. Within 3 weeks, it spread to 2 other groups, carried by the informal network of maintenance knowledge that kept combat units functioning when the formal supply chain was too slow. The solution to the second problem came from a briefing change rather than a hardware change. The fuel management procedure was revised so that the external to internal tank switch was always performed in level flight, or shallow dive, never in a bank greater than 15 degrees. This placed an additional procedural constraint on the pilot during the busiest phase of a mission, but it was a constraint that experienced pilots could manage, and the engine interruption problem largely disappeared from the incident reports. By February of 1944, the dual-tank system was operationally mature in a way it had not been in December. Not perfect. No combat aircraft modification ever became perfect, but reliable enough that the failure modes were understood, the workarounds were established, and the pilots who had initially refused the tanks were, with varying degrees of admitted reluctance, flying them regularly. The German fighter controllers, who had built their entire defensive strategy around the Thunderbolt's range limitations, were slow to recognize that the limitations had changed. This was not stupidity. It was a natural consequence of a system that had worked consistently for more than a year. By early 1943, every German fighter controller defending the Western approaches knew the math precisely. The P-47 Thunderbolts would protect the bombers to approximately the Belgian-German border. Past that line, the bombers were unescorted. The German fighter wings were positioned accordingly, held back behind the border, out of range of the American fighters, ready to descend on the unprotected formation once the Thunderbolts turned for home. The system was so reliable that German controllers had given it a specific terminology. The moment when the escorts departed was known within the Jaguar as Die Wende, the turn. Once the turn came, the signal went out to the waiting fighter wings, and the attack began. The B-17 and B. 24 crews had heard the German radio chatter about this moment enough times, intercepted by intelligence units and shared in briefings with a kind of brutal honesty that they knew the phrase. Some of them had written it in their mission logs. The first indication that Die Wende was not coming on schedule was reported by a Focke-Wulf 190 pilot from Jag-Eschwader II, based at Metz, who filed a post-mission report on February 10, 1944, noting that it engaged American single-engine fighters at position approximately 80 miles east of where the fighter escort was normally expected to terminate. His report described the encounter briefly. He had made a pass on AB-17 formation, was engaged by AP-47, and had broken off when the American aircraft pursued him at a speed and altitude inconsistent with the Thunderbolt operating on internal fuel alone. The report was filed. It was not immediately acted upon, partly because a single report of anomalous American fighter behavior was easy to explain away, a navigational error by the P-47 pilot, an unusually favorable wind, a miscalculation of time on station, and partly because the German command structure in early 1944 was experiencing its own internal difficulties, the kind that make anomalous data easy to ignore, when ignoring it is more comfortable than revising established doctrine. But the reports accumulated. It was in the first weeks of February that the 56 group's extended range capability was tested not in a carefully planned deep penetration mission, but in the disorganized, improvised, frequently fatal way that combat tests everything, by accident and necessity simultaneously. On February 8th, a formation of B-17s from the 1st Bombardment Division was struck by German fighters near Hanover. The escort Thunderbolts from the 56 Group were at the edge of their planned coverage zone, preparing for the turn home when the attack began. The attack was heavy and immediate. 2 staff on the Focke-Wulf 190s, approximately 20 aircraft, diving from altitude in the classic head-on pass formation that had devastated unescorted American bombers throughout 1943. The 56 Group flight leader that day was Major Francis Gabreski, who would end the war as the 8th Air Force's leading ace with 28 confirmed aerial victories. Gabreski's immediate assessment of the tactical situation was uncomplicated. The bombers were being hit, and he had fuel to continue. The dual external tanks on his aircraft still had approximately 40 gallons remaining combined. The fuel management doctrine said to stay in level flight before switching. The tactical situation said there was no time for level flight. Gabreski jettisoned both tanks immediately, made the internal tank switch in a 30-degree bank while pushing the throttle to military power, and drove into the attacking German formation. The engine interruption that the maintenance reports had documented lasted approximately 3 seconds by Gabreski's estimate. 3 seconds during which he was pointed at a German fighter at closing speed, and his engine was running on residual fuel. Then the pumper primed, the power came back fully, and the fight began. The 56 Group flight of 8 Thunderbolts engaged the attacking Germans for approximately 12 minutes at a position 305 miles from Boxted. The German attack on the bombers was disrupted. 1 B-17 was lost before the Thunderbolts intervened. 3 Focke-Wulfs were confirmed destroyed in the engagement. 2 more were damaged. The 8 Thunderbolts then turned for home on internal fuel, crossing the Dutch coast at reduced throttle settings to maximize range, landing at Boxted with fuel states that the post-mission reports describe variously as tight, minimal, and in at least 2 cases, almost certainly insufficient if the headwinds had been stronger. Gabreski's after-action report was notable for what it chose to emphasize. He did not dwell on the engine interruption during the combat entry. He did not recommend procedural changes to the tank switch protocol. What he wrote, in language that was concise even by the compressed standards of military reporting, was that the dual-tank system had allowed his flight to protect bombers at a range that would have been impossible 6 months earlier, and that the protection had worked. 305 miles from Boxted, the German fighters had not expected the P-47s to still be there. The phrase that appears in multiple post-mission debriefs from this period, in varying forms, is some version of the same observation. The German pilots seemed confused. They came in as if we weren't there. They had set up for a clean attack on the bombers, and they appeared surprised to find us in the way. It is a language of men describing an enemy that was operating on outdated information, and that is precisely what the German fighter controllers were doing. The Jagdwaff's tactical picture of American escort coverage was accurate as of November 1943. It was approximately 3 months out of date by February 1944. Those 3 months represented the time it had taken to fit the pylon kits to operational aircraft, train the pilots in the fuel management procedures, work out the jettison mechanism problems, and accumulate enough missions to build confident doctrine out of cautious experiment. The Germans had not kept up with this timeline. There was no reason they should have. The modifications had been developed under operational security. The range changes did not show up on German radar plots in any way that distinguished them from navigational variation, and the physical fact of Thunderbolts appearing over German territory at positions where Thunderbolts had never appeared before was, initially, simply disbelieved. This is the moment that the modification produced not a single dramatic battle, but a sustained period of confusion in German fighter direction that cost the Jagdwaff engagements it expected to win against unprotected bombers, and instead found contested by P-47s that had no business being there by the calculations that had governed German defensive planning since the beginning of the campaign. Hermann Göring, briefed on reports of American single-engine fighters appearing deeper over Germany than the fuel math permitted, reportedly dismissed the initial accounts. His argument that no single-engine fighter could maintain an extended escort radius over German territory was not unreasonable given what the Jagdwaff knew. It was simply wrong. The confluence of the P-47's dual-tank extension with the arriving P-51 Mustangs created a combined effect that neither aircraft would have produced alone. The Mustang, with its Packard Merlin engine and the paper drop tanks that had been developed through British experience, was a longer-range solution, Capable of reaching Berlin by March in 1944, a range the Thunderbolt could not match even with the dual external tank system. But in the critical months of January and February, while P-51 production was still ramping and Mustang groups were still converting and training, the dual-tank Thunderbolts of the 56th and the other P-47 groups provided coverage that extended the escort envelope incrementally but meaningfully into German airspace. They bought weeks. In the context of the bomber loss rates of that winter, weeks measured in bombers and crews. The 56th Group flew 23 missions in February of 1944 with dual external tanks. The average combat radius on those missions was 293 miles, compared to approximately 180 miles on comparable missions in November without external tanks. 13 of those missions involved engagement with German fighters at positions that exceeded the previously understood Thunderbolt coverage limit. In those 13 engagements, the element of Luftwaffe expectation, the assumption that the escorts had turned for home, was documented in the combat reports with enough consistency to constitute a pattern. The German pilots were not flying defensive profiles against the American fighters. They were flying offensive profiles against what they expected to be unescorted bombers. They came in fast, from altitude, committed to attack angles that left them exposed if a turning engagement developed. They were ambushed by the aircraft they thought had gone home, and the Thunderbolt, heavy, brutally powered, with 8 half-inch guns and a dive speed that could follow any German aircraft to the deck, was not a forgiving aircraft to be ambushed by. Lieutenant Robert Johnson, who had once refused a dual-tank configuration, flew 14 of those 23 missions. He shot down 5 German fighters in February. He would finish the war with 27 confirmed aerial victories, second only to Gabe Bresky among 8th Air Force pilots. In a post-war interview, he described the first mission on which he had pushed past the old escort limit and looked down at German airspace from 300 miles out. He said it felt like he had walked through a wall that was supposed to be solid and found it wasn't there. The institutional acceptance of the dual-tank modification moved faster than the original engineering skepticism had predicted. This is partly because combat data has a way of overcoming theoretical objections that laboratory testing cannot, and partly because the alternative, bomber groups losing 10% of their strength on individual missions, was clarified in a way that aeronautical stress analysis is not. By March of 1944, the pylon kits were being fitted to P-47 groups across the 8th Air Force as a matter of standard equipment rather than experimental program. The engineers who had written the June 1943 memorandum about unacceptable structural risk had not been wrong about the physics. The pylon loads under high-G maneuver entries with full external tanks did approach design limits. What they had been wrong about was the operational context in which the aircraft would actually be used, specifically, the discipline with which combat pilots would adhere to the jettison before maneuvering protocol once the risks of not doing so had been demonstrated to them in the unambiguous classroom of actual combat. Pilots who had initially found the fuel management procedures cumbersome and the jettison mechanisms unreliable had, by February, adopted the modified procedures of Majewski's improved release linkage as second nature. The failure modes that concerned the engineers existed in theory. They were largely absent from the operational record. This is not to say the engineers were simply overcautious. One P-47 from the 78 Fighter Group, fitted with the dual-tank pylon kit, lost a tank at high speed during a combat entry maneuver on March 7, 1944. The tank struck the left horizontal stabilizer and produced control system damage that required the pilot to make an emergency landing at an advanced airfield in Belgium. The pilot survived. The aircraft was reparable. The incident was documented, analyzed, and used to refine the jettison procedure further. It was, in the language of engineering risk management, an acceptable failure, one that produced useful data and no fatal outcome. 2 months earlier, before the missions had proven the system's value, the same incident might have been used to halt the program. In March of 1944, it was used to improve it. The broader story of the P-47's range extension exists in an interesting relationship with the P-51 story that is better known. The Mustang is, in retrospect, the right answer to the escort fighter range problem, more elegant, more extreme in its solution, ultimately capable of ranges that the Thunderbolt could never match. But the modification that gave the P-47 an extra hour over Germany was not a competing solution to the Mustang program. It was a bridge. It covered the months between the catastrophic losses of late 1943 and the moment when enough Mustangs were operational to change the fundamental nature of the air war. During those months, the difference between a Thunderbolt coverage limit of 175 miles and a Thunderbolt coverage limit of 300 miles was measured not in engineering specifications, but in B-17s that made a home. The bombing raid on February 20th through 25th, 1944, the operation the 8th Air Force called Big Week, the sustained assault on German aircraft manufacturing that inflicted severe losses on a Jaguar and consumed a replaceable German aircrew, was flown with a mixed escort force of P-47s on the dual-tank pylon kits and P-51s beginning to arrive in operational quantities. Neither aircraft alone could have provided the coverage that Big Week required. Together, overlapping their respective range envelopes, they produced a coherent escort umbrella over the bomber formations for a higher percentage of each mission than had previously been possible. The German fighters that fought during Big Week were contending with a problem that their tactical doctrine had not prepared them for: American escorts that appeared where they were not supposed to be, in combinations that did not correspond to force-structured Jaguars radar tracking and intelligence had mapped. The confusion contributed to a tactical hesitancy, an unwillingness to commit to the aggressive head-on formation attacks that had characterized the massacres of 1943, that cost the German fighter wings engagements they might otherwise have won. Colonel Zemke flew 37 missions in the P-47 with dual external tanks before the 56th Group received its first P-51 Mustangs in the spring of 1944. The group ultimately converted to Mustangs for the final phase of the European campaign, following a trajectory that most P-47 groups in the 8th Air Force eventually traced. But the dual-tank modification that Zemke had tested to the winter remained part of the P-47's operational profile throughout the war, used by groups in the 9th Air Force supporting ground operations and by fighter units in the Pacific Theater, where the range demands of island-hopping campaigns created their own version of the same fundamental problem. The statistics compiled by 8th Air Force Statistical Control Division at the war's end examined the impact of the external tank program on P-47 effectiveness. Between October of 1943 and April of 1944, P-47 Thunderbolts with external tank capability flew 34,070 combat sorties over Europe. Average combat radius extended progressively from 180 miles to approximately 310 miles as the dual-tank system was fully integrated. The proportion of escort missions that provided fighter coverage for the full inbound leg to the target, rather than the first portion only, increased from approximately 40% to 73% over that same period. The figures for bomber loss rates during the same period must be read cautiously, because the improvement in escort coverage was concurrent with the introduction of the P-51, the attrition of experienced German fighter pilots, and the broader deterioration of Luftwaffe operational capability that accompanied the sustained pressure of the strategic bombing campaign. Isolating the specific contribution of the P-47's extended range from these other factors is not possible with precision. What the combat reports do document, with enough consistency to carry evidential weight, is the repeated appearance of the word unexpected in the language German pilots and German controllers used to describe P-47 encounters in the winter of 1944. The Thunderbolt was not supposed to be there. The modifications that put it there were not supposed to work. On a gray morning in April of 1945, ground crews at Boxstead were loading external tanks onto the wings of P-51 Mustangs, the aircraft that had replaced the Thunderbolts in the 56 Group's inventory the previous summer. The war in Europe had approximately 3 weeks remaining. The Luftwaffe was grounded by fuel shortages across most of its remaining operational units. The missions being flown were ground attack sorties against transportation targets, not the desperate bomber escort work of 1943 and early 1944. In a maintenance hangar at the back of the field, 2 P-47 Thunderbolts were parked under canvas covers, awaiting transfer to training units in the United States. Both carried the dual-pylon external tank fixtures that had been standard equipment since the previous winter. The pylons were worn, the paint faded to a matte gray from thousands of hours of slipstream erosion. They were unremarkable pieces of aluminum and steel, holding nothing at that moment. Their purpose temporarily concluded. The mechanics walking past them had more important things to think about. The war was ending. They were thinking about home. The modification that those pylons represented, the addition of roughly 140 miles to a Thunderbolt's combat radius, the extension of an escort envelope that had been killing American bomber crews at a rate that threatened the entire strategic bombing campaign, the bridge that had been built between the catastrophic losses of late 1943 and the transformation of the air war that came with the full deployment of the P-51, was not a story anyone was telling at Boxstead on that April morning. It would not become a story anyone told for decades. The P-51 Mustang was the aircraft that saved the daylight bombing campaign. That was a story, accurate in its essential truth, even if simplified in its attribution, and the P-47 Thunderbolt's dual-tank modification existed in the footnotes of the footnotes. Known engineers and a handful of aviation historians, absent from the popular accounts that shaped how the air war over Europe was understood. Carl Bellinger, who had pushed the program from the drawing board into operational service against the formal objections of Wright Field, returned to Republic Aviation after the war and continued working on fighter aircraft design. He received no public recognition for the dual-tank work. The engineering memoranda documenting his arguments for the program and the test data supporting its combat deployment were filed in Republic's archives, declassified decades later, read by specialists. Sergeant Anthony Majewski, whose modification to the jettison linkage had solved the cold weather release problem and spread informally through the 8th Air Force's maintenance network, received no official recognition for the change. He was not the kind of man who expected any. He had fixed a problem because the problem needed fixing, and he knew how to fix it. That was what a crew chief did. Colonel Hubert Zemke, who had flown the dual-tank configuration personally before asking his pilots to fly it, who had built the 56th Group into the most effective P-47 unit in the 8th Air Force, was shot down and captured in October 1944, not by German fighters, but by clear air turbulence severe enough to structurally compromise his aircraft, which had nothing to do with external tanks, and everything to do with the routine brutality of flying at altitude over Germany at any point in the war. He survived as a prisoner of war. He was liberated in April of 1945. Major Francis Gabreski, who had made the combat entry with external tanks, still partially full on February 8th, and pushed the Thunderbolt past a range limit the German controllers had mapped so carefully, ended the war as the 8th Air Force's leading ace. His 28 aerial victories included the 5 scored in February of 1944, when he had taken his Thunderbolts into German airspace at positions where Thunderbolts were not supposed to be, and found German fighters configured for killing bombers rather than fighting escorts. Those German pilots had done the math. They had calculated the fuel loads, the combat radii, the position of Die Wendy, and they had been right. The math they were using was simply 3 months old. The lesson that lives inside this story is not primarily a lesson about aircraft or fuel or engineering. It is a lesson about the relationship between accepted limitation and actual limitation, between what the calculations say a thing cannot do and what the thing, once modified, once tested, once flown by pilots who had a pressing reason to find out where the real limits were, actually proved capable of. The P-47 Thunderbolt's range limitation was real. The engineers who calculated it were not wrong. The modification that changed it was not elegant. It was improvised, operationally developed, refined through failures in combat conditions rather than in test facilities, and extended by unauthorized field modifications that never appeared in any official engineering document. It was the kind of solution that a formal procurement process would have taken 18 months to develop and certify. The combat urgency of the winter of 1943 and 44 produced it in 6. The cost of the dual-tank program, in terms of aircraft modified, engineering hours invested, and the structural incidents that the modification did produce, none of which were fatal, was negligible compared to its operational value. It extended the Thunderbolt's escort coverage by roughly 40%. It contributed to a period of German tactical confusion, during which bomber loss rates began, for the first time in the European campaign, to fall toward levels that were sustainable. It bridged the gap between the disasters of Black Thursday and the arrival of sufficient Mustang strength to transform the air war decisively. Between October 1943 and May of 1945, 17 flying fortresses NB. 24 liberators flew approximately 332,000 combat sorties from English bases against targets in occupied Europe and Germany. The loss rate per sortie declined from approximately 5% in late 1943 to under 2% by the spring of 1944 and below 1% by the war's final months. The factors driving that decline were multiple and interrelated. The P-51's long-range escort capability, the attrition the Jaguars experienced aircrew, the improving accuracy and defensive armament of the bombers themselves, and the sustained pressure of the strategic campaign on German fuel production and pilot training. The dual external tank modification on the P-47 Thunderbolt was one of those factors, not the largest, not the most celebrated, but in the specific window of time when it mattered most, when the Mustangs were still arriving, when the German fighter force was still formidable, when the bomber crews were still dying at rates that threatened to end the daylight bombing campaign before it achieved its objectives. It was there. The engineers at Wright Field who wrote that the modification introduced unacceptable risk were looking at a stress diagram. The pilots who flew it were looking at bomber formations being destroyed at 30,000 feet, and they had a different sense of what unacceptable meant. Both perspectives were honest. Only one of them was flying. At the National Museum of the United States Air Force in Dayton, Ohio, a P-47 Thunderbolt sits on display beneath the high ceiling of the World War II gallery. The aircraft, serial number 42-83663, served with the 56th Fighter Group at Boxstead during the period under discussion. Its external pylon fittings are present, though no tanks are mounted. The museum placard describes the aircraft as representative of the Republic P-47 variant, notes its armament and power plant specifications, and identifies it as one of the primary escort fighters of the 8th Air Force. It does not mention the dual external tank modification program. It does not mention Carl Bellinger. It does not mention Sergeant Majewski's field-modified jettison linkage, or the Wright Field memorandum that nearly stopped the program, or the February missions on which Thunderbolts appeared over German territory at positions 300 miles from their base and found German fighter controllers unable to reconcile what their radar was showing them with what the fuel mathematics said was possible. Most visitors pause for a moment in front of the big round radial engine and move on. They see the machine. They do not see the hour it gained. That hour, the 140-mile extension of a combat radius that the calculation said could not be extended, tested against formal objection, proven in combat by pilots who understood that the alternative to flying further on an improvised modification was watching bombers die within sight of their own airfields, is a part of the story that does not fit on a museum placard. It fits here. Captain Shannon flew 6 YB-40 missions and tested the chin turret that went on to protect 8,680 bombers. Sergeant Majewski modified a jettison linkage in a maintenance hangar and solved a problem that was killing the range extension program from the inside. Bellinger argued against the memorandum and flew the aircraft before anyone else had to. Zemke flew the dual tanks himself before asking his pilots to carry them over Germany. None of them were making history the way history is usually described, with speeches and medals and formal recognition. They were solving problems in the dark, under pressure, with the war moving faster than the supply chains and the engineering departments and the official approval processes. They were building the bridge while they were walking across it. The bridge held. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.